Well, hi, good morning. Thanks so much for joining me in my shop as I start on a new project. This, I'm sure that's a Sylvania clock radio, which I know nothing about. I don't know if that's kind of, can you see that in the camera? It's kind of a mottled, yeah, you can see kind of a mottled look there, but I don't think that's the way it's supposed to look. I think it's supposed to be a nice, consistent gold, something like that. Instead, it kind of looks like that. Oh well, okay. What's going on in the back here? Cord is getting stiff, but it's still okay. Not cracked anywhere. Looks like it's been in this elastic band for a long time. Not a good sign. A little loose and floppy there. It's got the antenna connected to it. Let's see the wires over here. Let's attach that back because it's actually attaching to the radio chassis. Then we're just going to pull the radio out. I don't dare try this without first examining it. So it's up. Kind of weird how that fits. It does fit, sort of. Okay. Let's go off here. There's the radio dial. Okay, so when you pull knobs off and you see these long shafts, that's a strong message that there's a live chassis in here. This is connected to the clock motor. The clock motor and the clock housing may be electrically isolated from the chassis. It may not be part of it, so you can grab this safely. This screw, I don't think this is a good idea. I think this brings the chassis voltage right out. We'll find out. It's a bit of a mystery. Likewise, these screws can also be live. That's a very bad situation. Then you pick the radio up, stick your fingers underneath while you're beginning to carry the radio, assuming it's still plugged in. You can't be carrying it too far. Maybe moving it from something to something. Zingo. Right in the middle of carrying it. Now, what's going to happen here? Chassis should come out, the clock should stay back, the speaker should, well, the speaker may come out too. Let's see. Oh, the whole clock's coming out, the whole shooting match. That's good. Okay, what do we got in here? Asbestos down here. Doesn't seem to be. Looks like an aluminum sheet there. Pretty dirty. But no gold bars hidden in there. Once again, I'm gonna have to keep working. Okay. Lots of evidence that this has been in a moisture-laden area. In fact, I'm not going to pull that tube out. I'm going to let you take a look at it with the close-up camera in just a second. corrosion on here. Yeah, let's take a look with the close-up camera here. Still looking in the microscope. Okay, I think I got this set for really tight. That's okay though. Okay, let's take a look here. I see something pretty interesting in the background, but let's start here. A lot of flaky corrosion in there. You probably saw what I saw already. 12PE6. New capacitor. What I imagine is a new capacitor. This nice clean yellow guy. That's good. Okay, now, okay, so take a look at this. The tube here, you see the white on the top of it? So this tube has leaked. The glass is cracked and somehow air has gotten into it and it's gone like that. So this is the getter flash material, if you like, after getting exposed to oxygen. I believe that's what happens. It goes from being, you know, a shiny, reflective, dark color to white. So this tube is shot for sure. The other tubes are in place. Other than dirty, doesn't seem like the end of the world. Nice job on the antenna. How do they make corners like that with wire? Wow. It's almost hard to look at. How do they do that? Why do they do that? Hey, let's look underneath. Okay, I'm going to flip this guy right upside down. We'll see what's underneath here. Okay, as often is the case, top is filthy, underneath looks really good. Molded capacitor. A lot of wax capacitors here. Appear to be in good shape. Oh, what's this? It's another filter capacitor. Power supply. I wonder if the original capacitor wasn't in this area here and was replaced by this one and the one above. I don't know. There's the screw holding that. See, this piece here is cracked. And the bracket for this capacitor is stuffed under that screw along with the bracket for this. Well, maybe it's original and maybe it's a replacement. Okay, here's another capacitor here. Made in England. Yeah, it looks a little funny. Oh, that's not looking very good, is it? Yeah, I'd say that's probably got moisture in it. Volume control. Ooh, so it's actually a lead wire. I've ever seen anything quite like that before. How stiff are these wires? Not the worst thing going. Uh-oh, here's one of these integrated circuits here. Very, very early integrated circuit, and see the leads are all open, and that the covering here is not sealed. There's a good chance this guy's sick. If this guy is sick, it's trouble. Yes, it's trouble. Okay, volume control. One lead to go to the let's check out the power here. Let's check out the power, how this is done. So here's the power coming in. Still some flexibility in it. Connecting there. See 3 wires coming off that terminal. Okay, so one is going over here to this antenna coil, or oscillator coil, whatever it is, I'm not sure. And let's see, the other lead's going to this capacitor here. Okay, and the last lead, this black wire, is going around, it's going in behind this capacitor. What's that connecting to? That's connecting to a ground point, I think. That's what I'm looking for. Look with my own eyes. I don't think it goes to the ground. No, it's just going to this terminal here. Oh, surprise, look at that. What is it? Probably a capacitor, but I'm not exactly sure what that is. Whatever it is, it's bad news. Okay. Just look at any other of those. I don't see anything else like that in the radio. Just that one there. Okay, so where is the ground connection made to the chassis? In here. There it is there. Right on the end of this 0.05 volted capacitor. See, look at that, which then comes to this terminal, which then goes right to the power wire. So the chassis is tied to the power cord via that capacitor. What that means is if you do get a shock off this by touching the chassis and then grounding yourself. Let's see the plug again. I can't be polarized. This is too old to have a polarized plug. Right, there's nothing polarized about this plug, so it goes in this way or that. And depending upon whether the switch is on or off on the radio, the chassis may or may not be live. So the chassis is live through the capacitor because the live power line is connected here. If you touch the chassis and ground yourself, you're going to get a current through this capacitor. It's going to be restricted. So you're probably going to get a tingle shock and not much more. And that would be why they would leave. So here's where the base screw is exposed, and the antenna bracket, which is just riveted onto the radio, so the screws. So these things are shock points exposed. Of course, if this capacitor were short inside, you'd have a more exciting time, but the chance of this being short is very, very small. So that's what's going on with the chassis. That's probably the single connection to it. It probably means the capacitor, tuning capacitor, is insulated away from the chassis. Let's see if we can see that. In fact, you look right down here through these large holes. You can see what looks like a rubber, a black rubber piece, and there's some rivets. There's a rivet there. There's a rivet there. Okay, what's going on here? So see the rubber piece very clearly. There can't be any question that it's trying to isolate away this bracket from the chassis. So how do they hold this? Where do those rivets go? There's a rivet right in here. Okay, once again, what's holding this to the radio? I've gotten a shock off this kind of thing before, which is why I'm a little cautious about it, where I touch the this part of the radio and then touch the chassis too, and I got quite a shock off one of these doing that. So there's the trimmers. So what are those screws up on the top? So you know what, I think the rubber piece is held to the radio, and then this capacitor is screwed onto the rubber piece. That would mean the capacitor would be pretty movie. Let's see how movie it is. Oh yeah, it is pretty movie. So that's what they've done. They simply got our big rubber sheet in there, and they've attached the capacitor to the sheet using these screws. Meanwhile, the sheet has somehow been riveted in some fashion. Somehow, I don't know how. Riveted. How do you rivet a piece of rubber? That's what it looks like to me. Okay, so those are the danger deals. Maybe the last thing is there a transformer on the speaker? And I don't think there is, because I see one back here. So again, this is almost certainly the output transformer, which means the wires that run up to the speaker are just signal wires for the speaker. They aren't carrying any B+. So next question, do we turn this guy on the way it is? Well, obviously not with that tube. Otherwise, do we turn it on the way it is? Sure thing. You better believe it. How else do you get some excitement in your life? Okay, over you go. Now, this is going to have the typical tubes in it. When you look at the tubes, you'll see 3 shorter ones and 2 taller ones. 2 taller ones are taller because they're hard-working tubes. One of them is going to be the rectifier, and one of them is going to be the output tube that's driving the speaker. So this one I can see is a 35W4. This is the rectifier here. Take it out. This is the made in Japan. CGE. Okay, so CGE, what is going on here? That's Canadian General Electric. Made in Japan. Plugged into a radio built by Sylvania. With a capacitor in it from England. Oh, this is like an international radio here. So let's see if we can figure out why this thing has leaked. The top doesn't seem right. It seems. Hey, let's put on the close-up. Quick to the close-up camera. Let me just turn on my own big screen here so I can see better what's going on. Okay, so see the top. Doesn't look right. That's what right looks like. Very weird. It looks like there's a... So this might be a manufacturing defect in a sense, and they finished off the top here. It didn't quite come out right. Okay, so maybe there's another crack. Maybe there's another crack. They often crack in the base. Oh, there it is. Crack in the base. Through one of the pins. Right through the base. Right up the other side. So this is the problem. So these tubes run hot. And rectifier tubes. Made to CGE specifications. Obviously their specifications weren't the best because it cracked in the end. 35W5. Okay, I gotta go dig up a 35W5. Okay, so here's a little look at how I sort tubes. Not terribly anal about sorting them. So in some cases, if I have many of the same kind of tube, I'll put them in a bag like this. Because of these ones, these are various. This might be all kinds of tubes in here. This might be unsorted or something. But I can, have them in a bag, isolated. Now this is my long tubes. So just on the fact that the glass tube is long, it goes in this bucket. And I know I'm looking for a long tube, I'm going to find it in this bucket. Okay, that's how I sort them. I don't go any further. Now I got to rummage. But I'll take the tube I'm looking for and I'll look inside it. You see how it's structured inside. It's a very thin plate with a bit of a fan on this side. That's what I would call it. So I know what I'm looking for now. Now I just look in the bucket and try to pull one right out. 35W4. See if I can do that again. Can you do that again? Just reach in the bucket, pull out a 35W4. So that's what I discovered about storing tubes. This is probably a 35W4. Yeah, 35W4. Is that has a, when it comes to having I got 500 or 600 of these tubes around. Half of them are useless. Half of them are TV tubes. They're all kind of mixed up to some degree. I've sorted them a little bit, like you see, and then I've learned that the look of the tube is extremely helpful when you go to find it. You don't need to sort these things out into each little drawer and no. But how often does somebody go through their collection of tubes? See something like that? The look of it, you can spot that from a mile away. You don't have to read the number on it. But you have to know what bucket it's in. This big monster here, what is this? Looks like 35W5. No, it's something different. See the way it's structured inside, so the number's messed up here. You can see W5, but I can't see the rest of it. Anyway, that's how we do it. Let me save this to put in the tester at some point just for fun. Now I got 3 potential replacements, but they could be dead. They could be duds. So what? If I put them in the radio and try it, and let's say the filament's burned out on one of these, who cares? Nothing will happen. The worst thing is it could have a short in it. Now, that's a serious problem for a radio. pretty sure if I put in a shorted plate rectifier, my dim bulbs are going to save me. So on that basis, let's put in one of these. Dim bulbs for a dim technician. Okay. Okay, so the power's off on the panel here. I got lots of places to double check that, by the way. This meter, this meter, this meter, all tell me the same thing. So lots of opportunity to realize something is live when it's... Tighten up the antenna here a little bit. Okay, get your money out. What do we bet on this? Okay, there's two parts. It's got a clock and a radio. My bet is the clock will turn, but it'll make noise. It'll go ching, 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 like that. And the radio will not work. That's my guess. I got no idea. Better get the controls under control here. Okay, so on off has to be this, has to be on the clock because it's not in the control here. So the little knob is missing. On, off, auto. Okay, now bearing in mind I'm going to put a tool on this, this gives me an awful lot of leverage on this knob thing. Okay, so auto, off, on. So we're going to start in the off position. Off. Off position. So the clock should go and the radio not. Okay, here we go. Dim lights coming in. They're just up there. Oh. Now that certainly indicated the radio's coming on. See the clock's moving. Just lost my bet on the shing 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 sound. Okay, you can see this tube's warming up. These tubes are all in series, so if one is glowing, they're all glowing. They're all working. I do hear a bit of a hum. So we're running with 110 volts, which is just fine. Oh, just turned itself off. Did it? It's still lit. Ooh, what's the action here? I haven't even turned. What was that? It's getting louder and louder on its own. So the thing is, I've got this, well, no, it's 100 and, it's almost full voltage here. Old spider. Just looking for sensitivity. Okay, man. There's no way this should light. Turn this down. So the radio is plugged into an isolation transformer, so this is the neon light. Should not come on. Did not. See what we get. A rattly speaker. Turn it down a little more. expect to get stuff down here somewhere. Dirt in the volume control. .640. The 640 is right. I think somebody actually penciled a mark on it. 640 is there. So where are you supposed to look to know where the number is? The mark here. I think that's the original mark, this one here. And that would work out pretty good. This would be just about pointing at that. Yeah, it all adds up. Okay, what should we do about this radio? There's no hum. I don't think we need to do anything. Clean that volume control. So this radio is owned by a shop in Toronto, and they hope to sell it. They acquired this radio for no money, $1 or $2 or something like that. But they're not going to sell it for much money either. So I can't very well be charging them $100. And recapping this radio is not going to impress anybody. What's going to impress people is the fact that it works. It already does that. So it's already an impressive radio. I don't know what, I should have left it on here. I'm going to do this. Well, it's going to get too loud, so I'll go ahead. I'm going to clean the volume control there, just in case you're not a regular viewer and you don't know what I'm talking about. This is something that just so many electronic things get into trouble with dirt inside the control there. See the moving part inside? The dirt can go right in there. So we're going to hose it through this opening here. Blam, blam. Isn't that so good? That's a little much. Goodness knows that'll do it though. I would like to mop up some of the excess there. No. It's foamy, you know. It looks like more than it actually is when you first spray WD-40. That's pretty much it for this radio. That was it. The value I can add here to this guy is all about cleaning it. What about this rattly speaker? So I'm trying to feel the voice coil, which is back in here, which is going in and out of the magnet, to feel if it's dragging or rubbing. I don't feel anything. Of course, I can only push it in. You know, I have a little bit of trouble pushing it the other way. I don't know. I don't feel anything. I certainly heard it. Heard a sound like that. New rectifier tube. Okay, so let me clean this whole guy up, put him back together. We'll give him one last test. We'll see how that turns out.